Hey there, welcome to Math 70. This is the video for section 1.4. It's called Linear Inequalities. So just a quick review, an equation has an equal sign like 2x plus 1 equals 11. And to solve means to find the x that makes this equation true, which we do by subtracting 1 from both sides, dividing both sides by 2, and we get x equals 5. This is the example I've been using for the past couple of videos. So an inequality, or at least a linear inequality, means instead of x equals a number, maybe x is less than a number, or more than a number, or it could be equal to or less than, or equal to or more than. And I'll show you examples of each of these and what the notation looks like. So if I say x is less than 5, I'm going to use the notation x, and instead of an equal sign, I use this pointed brace, I guess. It's called the less than sign. And this means x is less than 5, so x could be a whole range of numbers. Like x could be 3, or x could be -2, or x could be 4.9. But no longer do I have a single number, but a whole range of numbers. X is, before I move on, the number that x can't equal, it can't be 5 or 6 or even 5.1 because it has to be less than 5. That's what this symbol means. X is more than 5. We turn the symbol around. And sometimes we write it where we put the 5 on the left. This would, if I were to say this in words, this is 5 is less than x, because x is more than 5. Those are what are called strict inequalities. Write that down. These are strict inequalities because they have to be either more or less. They can't be equal. The other type of inequality, I don't think it has a name. But it allows x to equal the number or be less. So if I say x is less than or equal to 5, I still use the less than symbol, but I put a horizontal line underneath it because that means it's kind of like an equal sign and also a less than sign. And the other option, as x is more than or equal to 5, I would say x, and then I would use the greater than symbol with the horizontal line. That's the greater than or equal to, more than or equal to. Yeah, another word for more, by the way, is greater. So I'll probably say one or the other sometimes. I don't know that there's another word I use for less than. More than and greater than are the same. Okay. Here we're going to start seeing the value of a visual representation, because not only can I do x is less than 5 with symbols, if I make myself a number line that represents all the numbers, and I mark a 5 right here, then any number here is less than 5. So all of this represents possible values for x, but 5 doesn't. And so there's two ways to do this. I'll show you one way first. We put like a parentheses right there, an open parentheses tells me I cannot include 5. Or some books, instead of a parentheses, we'll put an open circle around it. Those mean the same thing. That's x is less than 5. So reading this, I say x is less than 5. I better put a line here because I switched. Visual number line. X is less than 5. I can represent as a number line where I shade in all of the numbers to the left of 5. This also makes it really easy for me to do inequalities that contain more than one part. For example, I could say that x is greater than or equal to -3, but less than 2. So I could say, well, x is greater than or equal to -3, and x is less than 2. But I can squish this together if I flip this first one around and say -3 is less than or equal to x, and x is less than 2, and all of a sudden I have a much more compact way of writing x is greater than or equal to -3, but less than 2, and less than 2. And my number line would say x is greater than or equal to 3, x is greater than or equal to -3, and x is less than 2. It's less than 2, so I'm going to put this parentheses. If I want to include -3, I use a square bracket like that. And now I can shade in the part of the number line that refers to everything between -3 and 2. It includes -3, but it doesn't include +2. All right, so that's a basic how you write inequalities using symbols and using number lines. And now let's look at solving some inequalities. Let's solve 5x minus 3 is greater than -6. So what that means is find the range of x values, or I'm not going to use the word range, we use that word in a different way. The set of x values that make this statement true. It's not going to be a single x because there's a lot of values where you can do this arithmetic and still be less than -6. There's a couple different ways to solve this, but my recommendation to you is first change it to an equality, because that's what we've been working on. You've been doing equalities so far, so why not use that skill? That way you're only adding a little bit more to your mathematical landscape instead of trying to start from scratch. So I'm going to solve 5x minus 3 equals -6. And I have the tools for that. That's a two-step linear equation. Let's add 3 to both sides. And I get 5x equals -3, because -6 plus 3 is -3. Divide both sides by 5, and I get x equals -3/5. This is the end of my solution interval, my solution set, which we call an interval. An interval just means a range of numbers or a set of numbers from one to another. So if I were to draw this now, I would say, okay, here's 0. Let's call this one here -3/5. I know that's the end of my interval. What I don't know is, should I be on the left side or on the right side? If we look back at our previous example, 5 is the end of our interval. And here we're to the left of 5 because we're less than 5. So I need to take this equality and turn it back into an inequality. And the easiest way to do that is to test a point. Test a point to find out if the interval is on the left or the right of your endpoint. Now, this is not the only way to solve linear inequalities, but this is the only way to solve some inequalities that are coming in your mathematical future. So I think it's worth building this skill at this point. So we're going to test a point, something easy. I've always found 0 to be the easiest point. So let's test x equals 0. The only time you can't test it is if that is actually your endpoint. So let's test x equals 0. Let's put 5 times 0 minus 3, because that was our original inequality. 5 times 0 minus 3. Let's see what we get. Well, 5 times 0 is 0. That's -3. And my question is this greater than -6? Because that was our original inequality. -3 is, in fact, it is greater than -6. Right? Because if I have -6 here, -3 is here, it's greater than -6. So that means x equals 0 works. So I come up here to my number line and I say, aha, well, that point works. Yeah, but then this point should work because that would be even bigger. And this point should work because that would be even bigger. In fact, any point in this area, in this part of the number line, should work. And the last question is, do I include the endpoint? Decide whether to include the endpoint. From this, you look at the inequality. Look at the inequality. If it looks like that, it means don't include. If it looks like that, it means do include. All right, because the strictly less than means you cannot include the endpoint, but the less than or equal means you can. And the same if it's greater than or greater than or equal. So we look at our original inequality. It was a strictly less than, which tells me that I should not include the endpoint 5x minus 3, sorry, strictly greater than -6 means don't include the endpoint. So here in my number line, I'm just going to make it an open parentheses. Aha. So now if you want to write the solution set as an inequality, you take your number line and you say, okay, well, the endpoint was -3/5, and x always had to be bigger than that. That's my solution set, which I could also write as x is greater than -3/5, right? Because those two are equivalent. So this page right here gives you everything you need to know to solve any inequality. No matter what inequality you see in this class or in your future, you can solve it this way. First, you change it to an equality, and you solve the equality. Then draw yourself a picture. Test your points on either side of your endpoint. Here, x equals 0 works in my inequality, so that means everything on the right side works. And then you have to decide, well, what about the endpoint itself? Look at your original inequality. If it's a strict inequality, then you do not include the endpoint. And then you can write your solution set as an inequality. That should say inequality there. Let's do one more. The nice thing about this method is even very complicated inequalities, if we follow this process, it turns back into something that we are already more comfortable doing. Negative 11x plus 19 should be less than negative 12x plus 3. That's a fairly complicated inequality. So first we're going to solve the equality. And I'm going to change this before we do anything else so we get practice solving the other type. So negative 11x plus 19 is less than or equal to negative 12x plus 3. So we turn it into an equality as our first step. We're going to find out where they're equal. Let's see, get all the x's on one side. So let's add 12x to both sides. And we get x plus 19 should equal 3. And then get the numbers on the other side. So we'll subtract 19 from both sides. And we get x equals negative 16. That's the end point. So 2, draw the interval and test a point. I'm not going to worry too much about scale here. I got negative 16, so let's say that point is negative 16 there. I have lots of options for my endpoint, but I'll tell you the easiest option is usually the 0. Let's try it. Let's try x equals 0. So we'd have negative 11 times 0 plus 19. And we want to know if that's less than or equal to negative 12 times 0 plus 3. 0 is so easy to test because those pieces drop out. And we're asking ourselves, is it true that 19 is less than, or sorry, we're asking ourselves, is it true that 19 is less than or equal to 3? Not true. That means 0 is not part of our solution set. So nothing on this side is part of our solution set, which means everything over here probably is in our solution set. We could test a point. That's not a bad idea. A point smaller than negative 16. We could pick negative 17. The math's a little tricky. 11 times 17, but we have calculators. I'm going to pick negative 20 because that's something I can just do in my head. So a negative 11 times 20 plus 19. And I want to know if that's less than or equal to negative 12 times 20 plus 3. Okay. Negative 11 times 20 is, let's see, negative 220 plus 19. And negative 12 times 20 is negative 240 plus 3. It's fine if you're not going to do this calculation in your head. That's what calculators are for. I just don't have a calculator super handy right now. But it's also, I think, important to keep in mind as a mathematician, it's like, this is a nice method because you don't have to be super precise. I don't have to test 15, I can test 0. I don't have to test negative 17, I can test negative 20. I could test negative 100 if I wanted. All right, let's see what happens. Let's see if I got this right. Well, I know I did something wrong. I want to point that out to you. I said I was going to pick x equals -20, but I actually put +20 in my parentheses, so I have to fix that. So a -11 times -20, which should be +220. And -12 times -20, which should be +240. And now I'm going to get the right answer, thankfully, because otherwise that wouldn't have been very helpful. 220 plus 19 is 239. 240 plus 3 is 243. This is true. So -20 down here works. So all of those numbers down there work. By the way, this is a good opportunity to say typos happen a lot when you're doing math. I've been doing math a long time and I still do silly things like drop a minus sign. It means you get the wrong answer, but it doesn't mean you're bad at math. So if and when it happens to you, just notice it. Once you figure it out, say, whoops, that happened, and keep on going. If you ever are going to be doing something where it's critical that math typos don't happen, I promise you that you will have somebody else checking your work to help you catch those. So try not to make these typos, but if it does happen to you, just give yourself a little bit of patience. Okay, so we found our endpoint -16. We tested our endpoints. We know the interval is to the left. And so now we have to decide whether to include the endpoint. So we look at our original inequality, which was -11x plus 19 less than or equal to -12x plus 3. Since it's a less than or equal, we're going to include the endpoint. So if I add it to my picture here, I'm going to draw a square bracket. And if I want to write the solution set as an inequality, it's going to be x should be less than or equal to -16. And we're done. All right, that'll do it for this section. And in fact, that finishes chapter 1, I believe. And so our next set of videos will start chapter 2. Thanks for watching.